welcome to Data Platform Summit 2022. I'm Ed Pollack. I'm here to have a wonderful romp through all of the new T-SQL found in SQL Server 2022. This is an excellent opportunity to learn about the new features that can allow your code to be better, simpler, tighter, easier to document, and probably faster too. A lot of fun. This is a good time, and it's worth always investigating new features. This is me. I'm Ed Pollack. I have been doing this for a while. I have published books, articles, presented at many events. I love playing and working with data. I've organized SQL Saturdays and other events. This is fun to me. So this is kind of an enjoyable thing, new features, new toys, things to play with. Feel free to ask questions of me later on. Feel free to hit me up on social media. I'm always open to discuss all the cool new things that are out there, or maybe things that are not so good, or maybe missing. Any of those things are fun. So conversation's great. I do love it. Let's get right into it then. Really simple agenda. Really just going to do an intro onto what new features are, why they appear, and how we control them and deal with them with compatibility levels. And then the rest of the session is simply going through all of these features. That's why we're here, to discuss all of them. This has been done as of SQL Server 2022 CTP 2.1, Community Technical Preview 2.1. Therefore, if you have an older version, you might be missing a few of these things. If you have a newer version, perhaps you watch the session later and things have changed, there might be some new features I don't have here yet. But this is everything there is as of August 19th, 2022. Pretty good. This is full of demos. Hopefully they all go great. If not, we'll get a wonderful laugh, I promise. And then we'll wrap up, and then we can all do the QA thing later on and see if we have any questions about what we've done here. The key here about new features is they keep coming. They are always here. Every version of SQL Server, and oftentimes even minor versions, updates, CUs will have new T-SQL syntax, new columns, new things available that were not around before. This is a big deal. This means that every time you upgrade, you're getting new functionality, ways to write better T-SQL, T-SQL that performs better. And a lot of times we get buried in all of the new big features. When a new version comes out, everyone talks about, wow, look at Azure Synapse, or wow, availability groups got better, this is amazing, or we can do JSON now. And people go gaga over brand new features and often skip over the T-SQL. But to me, this is the exciting stuff. A lot of what we do is in T-SQL, and if we can make it better and perform better and easier to write, easier to document, easier to understand, less easy to mess up, that's a good thing. So without a question, to me, one of the first things I look at in any new version of SQL Server are the new T-SQL features. What cool things have been added? An important key to new features is compatibility level, and it's worth talking about this briefly. Compatibility level is a setting on a database that tells SQL Server how that database should behave. Primarily, compatibility level impacts performance. So if you have your compatibility level set to 140, that's 2017, the performance of the query optimizer will mimic what's in 2017 and do it very well. It is not a gatekeeper to features for the most part. In general, if a feature is available and there's no documentation in Microsoft Docs saying it isn't otherwise gatekeeped by a compatibility level, you could just use it, even if you're in an older compatibility level. So the primary goal of these levels is to impact behavior and performance, not features and functionality. Therefore, most of what we present today is available in, as long as you have SQL Server 2022, CTP 2.1 or higher, you'll have all this. And only a few of these features are bound by the compatibility level. The real purpose of compatibility level is to allow for nice, smooth, easy upgrades. If you want to upgrade from 2017 to 2022, you can do that, perform the upgrade, keep your databases in 2017 compatibility level, do gobs and gobs of testing, and then slowly bump it up to 2019 to 2022. And then if anything goes wrong, you can bump it back, because bumping that compatibility level back and forth is just a simple DDL operation. It doesn't require a restart of your server or your services or anything else. So it's very, very lightweight, easy to do, and it's a great way to ensure that if things do go wrong, you can fix them. Or if things are right, you can stay where you are. As of 2016, this is a guarantee. Microsoft stands behind compatibility levels and saying that your functionality and performance are guaranteed to behave the way they would have in that version. So if the optimizer got a bunch of tweaks in 2014 and you're in 2012 compatibility level, then it will work as though it did in 2012 in theory. That's what it tries to do. And in general, from 2016 on, it's guaranteed. Before 2016, it's a little dicier. But the guarantee is nice, though. If you're on a newer version of SQL Server, you have that guarantee things will behave the way they should. An additional note is that while many of SQL Server's features are available both in on-prem versions and in Azure versions, some are not. Obviously, if you're doing things that hit the operating system or try to hit storage or other various system resources that may not be available, you won't be able to access them. So just keep in mind, you can always check the docs if you're not sure. Sometimes new features will come to Azure first and be made available to the on-prem version later. If you're not sure, Microsoft Docs are pretty thorough with all the new versions of SQL Server and telling you what is available where. So real quick, speed demo and compatibility level. I'm going to take my database and bring it down to SQL Server 2019 compatibility level. I am now going to run a simple query that uses isDistinctFrom. This is brand new in 2022, so it wasn't available in 2019. It was made available in 2022. I'm running 2022 here, but my compatibility level is bumped down one. If I run this query, it works. It gives me back the count of orders that I wanted. I can bring it back further and say, bring it back to 08R2 compatibility level. Run the same query. Still works. SQL Server doesn't care. It's fine. My compatibility level didn't gatekeep me here, and nowhere in the docs does it say it should. So that's great. I get the performance I want, but I'm not stuck with old features only. I can use the new features that are available now. I'm going to go ahead and put this back into 2022 for future demos and keep going. We have lots and lots of demos today. If you love demos, this is great. Hopefully the laugh track will be minimal and things won't go wrong. Things are fun when they go wrong, right? The first new feature I want to talk about, and this is a biggie, it was kind of subtly dropped in, but I like this a lot, is distinct. You can do is distinct or is not distinct. And what this basically does is it is kind of like an equals or not equals, but it includes null. So if a column, a value is here, is different from a value here, in any way, it will be not distinct. Sorry, is distinct. Not distinct means the same. So this is really checking to see are two columns equal or not, or two values equal or not, but it won't care about null. Before this was available, you had to do kind of annoying things, like the is null of this comma -1 equals the is null of this comma -1, or this equals 5 and this is not null, and that is equal to 5 and that is not null. And that's complicated. It makes for long and ugly T-SQL, and it's just kind of annoying to write. And this is just a great feature to have available. It cleans things up and makes your T-SQL smaller, simpler, and easier to read. And you understand implicitly, this has nothing to do with ANSI nulls at all. It simply says, is this the same as this? Fundamentally the same. And it includes as null. A beautiful thing about this is the optimizer can use this. It can parse it in filters and group bys and whatevers and use it. So if you say, give me select from a table where a column is not distinct from another column and they're indexed columns, it will use those indexes effectively as though it were an equals or something else that you normally would expect to use an index. How does this look in T-SQL? Well, here we go. Here's what I might do sometimes. I might write a query that says, hey, select star from sales.orders, and I want where this pick by person ID is not 3. I run this, I get back 59,000 rows, but there's danger here. This is a nullable column, and because it's nullable, what I'm getting back is suspect. I'm incurring some ANSI nulls risk. Will I get the nulls or not? How will it behave? And the answer is it's not a very safe bet to play. If I want to get results more conclusively, I would write it like this. I would say, oh, give me my value, give me my rows back where the is null of it isn't 3. So I'm getting all the ones that aren't 3, and I'm throwing away the nulls by saying the nulls are 3, so throw them away. So give me every value of 3 and don't include null. I run that, and I get back the same value. Similarly, I can use new T-SQL to make this look a little better. So instead of having is nulls thrown in here that may throw off the optimizer and make my things perform poorly, I can now simply say select from my table where it's picked by person ID is distinct from 3. What this means is picked by person ID not 3? Not null, not 3. Is it anything besides 3? This won't be impacted by ANSI nulls because this is that kind of function. Now notice I got 70,000 rows back because null is distinct from 3. Any value that's not 3 is different than it, and null is also considered not 3. If I want this behavior, good. If I don't want it, I can manage it differently. The opposite of this would be for me to say, give me all of the rows where picked by person ID is not distinct from 3. In other words, give me all the rows where it's 3. Not distinct means equal. It sounds a little awkward that a not kind of implies equal, but that's how it works. I run this and I get all the rows where it's 3. Great. Again, this goes back into the old days. I could try to solve my problem using the old syntax like this to say, is null of it is equal to 3. That gives me the same results, but is that really what I want? It included null. Do I want null or not? I find in general that this is distinct and is not distinct is a wonderful syntax. It's simple, easy to understand, and you don't have to worry about ANSI nulls anymore. You know that it knows, this functionality knows what null is and says distinct means something different from whatever your value is, regardless of what else is. It could be null or not null. That's useful. This makes our lives easier. You can even do is distinct from null, and it knows what you're talking about. You don't have to worry about the issue of equal null breaking things or not equal null breaking things. So this is a cool functionality, a great addition, and it's an ANSI standard, so you now have it in SQL Server as well. Great. On a completely different note, here's kind of a fun one. Percentiles, this is essentially when we're looking for medians. Calculating any aggregate function that has to scan lots and lots of data tends to be kind of slow. If you want medians, if you want averages, if you want all kinds of like running totals and things, it can get expensive when you have a lot of rows. If you're talking about 1,000 rows, just do it however you want to do it. You'll get back a great value. It'll probably be very fast. If you've got millions or billions of rows, some giant table, even if it's column store index, even if it's compressed really well, it's going to take a while to scan that much data. It's going to order it too. Calculating a median requires ordering your data before crunching and figuring out what that middle value is. So percentile disk and percentile cont both basically are saying, give me a median. The percentile disk says, give me a value that is in my queried column. So get me the median value, and if it happens to be not one of the exact values, pick one and just give me the actual value in the set. Percentile cont says, calculate a middle value. So if there's some kind of average in the middle and I don't have an exact value, it'll just make a mathematical calculation of what the median is, but it won't be an actual value in the data set. But it will be the median. It'll be useful. The approximate functionality has already existed in SQL Server for a few other areas. The approximate basically allows SQL Server to, in a way, cut corners and calculate this much faster. The upside is you use way less resources, it's way cheaper, costs your server less, costs less cycles, your Azure bill is a little lower next month, that's always nice. But probably the most important thing is you get results faster. The key, though, is that it's approximate. Therefore, your median may not be exactly the value you expect, but it'll be close. How close? Microsoft guarantees 1.33% rank-based error within a 99% probability. That's pretty good. If you care about a ballpark, and you don't need exact, this is great. There are other approximate functionalities in SQL Server that do very similar things, and the general purpose of approximations is you want to know something, and the exact value doesn't matter. You want to know, is it 50 or 60, not is it 51.553 versus 55.335. You care about just a general ballpark, and if that's all you want, like you want to get a count or an average or whatever, you want to get it and understand just in general what it is, this is a perfect thing to use. It will get you an excellent ballpark number. You can get different values, though, when you execute it at different times because it's an approximation, and that algorithm may or may not give you exactly what you're looking for, but it'll be very, very close. You may get a different value, but it'll be very, very close. So again, you're not here for precision, you're here for a ballpark, and if that's all you want, this is perfect. So let's jump in really quick and take a look. Here is an example of some order line data. I get the salesperson ID, and then I do a percentile cont and percentile disk to get my values. I'm looking here really to see for each salesperson, what's their sales like overall, just their median. Who has higher median sales, who has lower. I look at this exact, and this is exact. I'm not doing an approximation here, but here's how it looks, and I can see there's my values. They're all relatively similar, not very exciting, but I get some results back. I can go, and I'm going to do side by side just so we can compare them. The second one here shows the syntax for approximates. So what's the approximate medians like here? And the syntax is similar. I do throw the group by down here now, but otherwise the syntax is very similar. So I'm going to run this and compare and see that in general, the results are very, very close, if not exactly the same. In fact, they're all exactly the same except for one value here that instead of 238, it came back 235.43, which again, as an estimated value, that's only off by, what, 1%? It's really good. So that's what we expect. A small, small error rate, that's good. So if you're looking for an approximation to a median and you want it returned faster, using less compute, this is the way to do it. It will save resources and be faster and give you back the results you want, assuming that exact precision is not what you want. And over a long period of time, if you're analyzing data, you'll find that trends are meaningful. If you trend this data over time, it will go up and down as you expect it to. It will not fluctuate in ways that are logical. You won't see it go down by 10 if the values all go up, for example. It generally doesn't occur that way. You'll find the estimations are pretty solid. All right. What's up next? Here's a simple one. In classic sense, this is very complicated to do, very annoying to do, and it wasn't very fun. How do you take a date time and remove a chunk of it and say, hey, I want this date time down to the minute. Just truncate it down to the minute and slice off the seconds, milliseconds, and that's all. And to do it before required getting date parts and constructing a date and then subtracting it and doing all kinds of weird stuff. Some people might take strings and remove string pieces, but all of it was ugly. It was very, very ugly. It was hard to read. It was hard to document. And it was easy to make mistakes doing. This is a great scenario for a function to just fix this and fix it effectively. We can see very easily how this looks. So let's take the current date time and just truncate it down to the day. If I run that, I see that I now have 8/19/2022 and all the rest has been zeroed out. I can do it to the second, and you'll see now that I have my current date time sliced down to the second. All the milliseconds are removed. This is really cool. This means I can now very quickly and efficiently take a date time and slice off whatever chunk I want. And one of the real uses for it is for filtering and grouping. I can say, hey, I want to know all the orders where the hour truncation of a date is down to this. Give me everything where it's like this. So automatically truncate my date time down to the hour and see is it equal to this one. I can do that and get back results pretty fast, just like that. Before, this would have been more complicated with more T-SQL and more staging of data or ugly strings and things like that. So again, cleaner, simpler, less text, easier to read. Similarly, we can group by it. And this is where we can get very useful for analytics. We can say, hey, I want to group by a truncated date. Take my date time, truncate it down to the hour, the day, the minute, whatever, and then group by it. And I don't have to get every date part and group by. That's how you used to do this, right? You used to say, hey, group by the date, hour, minute, and you'd group by all of that, and it was ugly as heck, hard to read, and very hard to modify and not goof with. And it certainly didn't perform well, that's for sure. Here, I can say, I want to group by this thing rounded down to the hour. So take my picked hour, round it down to the hour, and give me back that date time. And I can see here I have some nulls, but I also have all of my other date times, and each one's been rounded to the hour and aggregated, giving me a total net sales here, quantity times price. That's pretty cool. Doing this before was complicated and messy. Now I can do it with one function. So this is really nice. Definitely a huge improvement in SQL Server. If you ever want to round down a date time or a date, this is wonderful. You can use any of the date parts you want. Day, week, hour, minute, second, millisecond, whatever you want. If it's in the date part list in Microsoft Docs, you can truncate down to it. And just remember, of course, that truncate means round down, not round up. So if you have the hours, if it's 1:23, you want to go down to the hour, it's going to go to 1, not 2. Just remember, truncate rounds down. Otherwise, no real other important notes in this. It's a very, very useful function. I like it. I'm sure I'm going to use it in analytics a lot, because otherwise the alternative is yucky. And I didn't even include the alternative here because it's yucky. And if you know what I'm talking about, you know it's yucky. If you haven't seen it before, you're lucky. Here's some fun stuff here with bits. If you need this and want it, it's there for you and wonderful. If you don't need it, you could probably just fast forward a little bit right now, put this on 1.5x and zip past a little faster. No biggie. But bit manipulation. Very often when you're playing around with more binary numbers, with hex, with just values, and you want to do some nifty things, divide by 2, multiply by 2, things like that, some of the most efficient ways to do those things are to muck with bits. And so SQL Server added a bunch of new features. Left shift, right shift, bit count, get bit, set bit. And I'm going to take all of these and demo them back in Management Studio now. Again, these are things that if you need them, they're great. If you don't, no biggie. So what do we have? Here are some demos of some of these functionalities, some of these functions. For example, left shift. If you have a number here, 100,000 or 10,000, the number is 16 in binary. I take 16, and if I left shift by 1, I'm taking that 1, bringing it over, and multiplying by 10. I get 32. If I left shift by 2, I get 64. All I'm doing is taking a number and shifting over the bit by 1. And that's it, shifting all the bits over. So 10,000 becomes 100,000, 100,000 becomes a million, and so on and so forth. Doesn't matter what bits I have in here, they all shift left by 1. This is a really cool way to manipulate and multiply things by 2 and not incur any real expense to do so. You don't have to go pulling out bits and doing horrible things. None of that is necessary at all. Right shift is the exact same thing, except that you're going to the right. You're dividing by 2. If I were to take my same number, 16, and do the same sort of math with it, I would see that 16 becomes 8 when I right shift by 1, and it becomes 4 when I right shift by 2. No big deal, right? Easy. It's something that if you need it, it's great. If you don't need it, no big deal. But again, this is all bit math. It's in the world of bits, not in the world of like numbers, octal, hex, or anything else. This is just looking at the bits, the straight up bits, binary representation of numbers. How about bit count? This is a weird one. How many bits are in my number? All right. What does that mean? Well, it's going to go in there and count up all the ones. That's what this is doing. For example, 16 is 10000. There's a single 1 in there. Therefore, the bit count of 16 is 1. Bit count of 15, well, that's 1111. 4 ones, 4 1 bits. Therefore, my bit count is 4. Bit count of 1 is 1. Bit count of 0 is 0. You get the idea. Do beware if you do negative numbers and you think you're getting what you think you're getting, it's not really. Negative 15 is not negative 1111. Negative in the bit world like this is going to be inverse. Inverse means you're swapping all your bits around. So if you do some of this funky stuff here, like bit count of negative 1, well, you're getting 32. Bit count of negative 2 is 31. Bit count of negative 7 is 30. Bit count of negative 2 is 15. 15. And then negative 32,768 is 1. So what you're basically doing is just inverting your number, taking all the 1s, turning them to 0s, 0s turning them to 1s. If you want to do that, that's awesome. Just be aware that that's what the negative does, though. It isn't necessarily like a negative number that's a bunch of bits. It's an inverse. So just keep that in mind. You're still positive numbers. They're all inverted. If what you really want to do is take and count the bits of the number, and it's a negative number, like negative 15 has 4 bits, even though it's a negative, you want to do the absolute value first. Just a tip. It's useful. So bit count of negative 1 now is 1 because I've absolute valued it. Same for negative 2, there's 1 bit. Negative 7, 3. Negative 2, 1. Negative blah, 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 1. We get the idea. So this is useful information. Just keep it in mind. You need to cast it, absolute it, whatever. Do what you need to do to get it to be right. But keep in mind that negative means inverse. Alright. Those are fun things. If you need to do bit math, this is wonderful. Absolutely wonderful functionality. If you don't, just keep in mind that it exists. You may have to go mucking around with bits in the future, doing some cool mathematical work, and this could make your life a lot easier. So just keep in mind that it's there. What's next? We can take now the creation of constraints and keys that have indexes and make them resumable. This is pretty cool. This is a wonderful boon for maintenance, where you may have very, very large indexes that require rebuilds. You're going through lots of large indexes, and you only want your maintenance window to be a certain period of time. You don't want to be running index rebuilds all day. You want them after hours when people aren't really using your systems as much. This is also a great way to allow you to pause for maintenance. Like, hey, I'm about to go restart a server for some reason. I don't want everything that's going on there to die, so I can do a pause and resume. This is really cool. So I can add a time limit, and then the ability to pause and resume as needed. This is, again, a great way to manage maintenance and make your life easier. So what does this look like? I'm going to go ahead and create a table called sales order lines test. I'm going to alter it and add a new PK onto this table. On line on, resumable on, max duration 15. I insert some rows into there, I'm done, and then I can alter it and take a look at it. I'm going to go ahead and grab this code and bring it over into a new window, and I'm going to run a rebuild and immediately pause it. Hopefully I can be speedy enough to do this, or have a failed demo, we'll see. And we can see what happens. So I'm going to run the rebuild and then immediately do it over here. I went a little crazy here just now. You can see my connection got terminated here. I was doing a rebuild, online on, resumable, max duration, and I paused it right in the middle. I said alter index, pause. So it paused that rebuild for me. It broke my connection, which is by design. I was doing a thing and got totally blown away. So I'm going to go ahead and put myself into a new window and reconnect. There we go. Go back up to the top where I was and continue. Awesome. Now I can go over here and I can look at and see what I got. There's a new system view that allows me to see which indexes have paused but resumable operations. And here's my list right here. This is awesome. I can see the name of the index, the SQL text for it, the state of it currently, and most importantly, what's the percent complete and the page count. So I have a lot of information here as to how it's doing. Is it mostly done? Is it not mostly done? How is it doing? And this is really useful. I can then go back here again. I can do my rebuild. I can check the status and see it's all done. This is great. This is awesome. A wonderful, wonderful, wonderful piece of functionality that allows you to take index rebuilds, especially on big, big tables, and make them resumable. Pause them when you need to. Let them take a break. You can automate this too. You don't have to do this yourself manually, and you shouldn't do it manually. But you can build your index maintenance processes to automatically say, hey, we're hitting the end of our window. Pause everything in process. We'll continue it tomorrow. Then the next day, you go to this view, check out which ones are in progress, and you can see them all right here. The SQL text gives you everything. You can simply run this again and continue what you left off, and then do all your new stuff on top of it. So wonderful, wonderful functionality, extremely useful. If you're a maintenance person and you care about index maintenance, this is a boon to your world. It will make your life easier, and you can do it now with PKs in addition to other indexes as well. So wonderful function, super useful, and if you're a maintenance person, beautiful. Makes your life much easier. More new functionality. Greatest and least. Finally, Microsoft, you brought it to us after all these years of waiting. Greatest and least. These are simple functions that essentially say, give me the largest and smallest value of different expressions. So I can put in there 5 values or 5 columns, and it'll return to me what the largest and smallest value are. This is not min or max. Min says, give me the smallest value for one given column or expression. Max says, give me the greatest value for any given column or expression. And that's wonderful, but what if you have multiple columns and you want the largest or smallest value out of all of them? Well, you can do that here. In fact, not as many as you want. It's actually limited to 254. But really, if you're putting 254 values into this thing, that's pretty wild. I kind of want to see what you're doing. It's probably going to involve some dynamic SQL or a very bored developer. One of those two. Anyway, you can put anything you want in here. It could be columns, they could be parameters, values, scalars, expressions, whatever you want can go in here. It can include aggregates too. If you've got a group by in there and you're aggregating, you can throw the greatest and least in there and chuck sums and mins and maxes. So you can actually greatest and least onto mins and maxes and counts and other things. So very, very useful. Lots of functionality here, lots of ways to use this. One useful note is that it will automatically convert your data types for you implicitly to whatever the highest precedence is. If you don't know what the highest precedence is for your data types, go to Microsoft's documentation, look up Microsoft SQL Server data type precedence. We get a wonderful list that you can pour over, get bored on, and drink to. How does this look? Well, I can simply say, select from some tables, join them together for a specific salesperson, and then, hey, I have a bunch of dates, and I want to know the latest and earliest for them. I first of all want to get the greatest of all these dates to get a last modified time. I want to get a least of all of these dates to get me a first modified time. So when I run it, I get back my values. And this is pretty cool. I can now see, like, for a specific salesperson, the first modified date for all of their orders was 1/1/2013, and their most recent one was 1/1/2014. 1 at noon. I can go through all of these and see all these cool values and go through. And this is great because I can throw as many columns as I want in here. Before this was available, I had to do some complicated things, like give me the min of this column, and then the min of this column, and the min of this column, and compare them all. If the min of this is less than the min of this column, then use this one. It led to very complicated case statements that were just not pretty at all, and made for very long, very messy T-SQL. But now, I can simply say for a scenario I want a min ID, or a minimum time, or something like that. I can simply say, give me the greatest or the least, I can throw all the columns in or expressions that I care about, and be done. This is really nice. This is a simple way to write something that otherwise requires lines and lines of spaghetti SQL that's very hard to read. For this second example here, where I have the least of 1, 2, 3, 4, 5 columns, this would have required basically a long case statement checking 5 different mins against each other to see which min is the miniest, least mini, smallest, however you want to say it, I guess. But that would have been messy. It would have been a big, long case statement, lots of case, if, then this, when, else, otherwise, and it would have been messy. Very, very messy. So greatest and least is a wonderful way to clean up scenarios where you have many different columns and you want the smallest or greatest value out of any of them, not just one of them. Another gift that came to us that we've been waiting for a long time is string split. This is huge. String split basically says, hey, I can take a string and implicitly split it up and get all the values out of a CSV basically, or delimit it by whatever you want. You have a delimited string, and I want to pull out all the entries from it. I can do that automatically with a function. I don't have to write up crazy T-SQL that involves XML or stuff or replace, or iteration through a string. I don't do any of that. I can just simply use string split and get what I want, and I'm done. And it performs pretty well. I do have the note here, it requires compatibility level 130 or higher. It's just how it's written. It's one of those exceptions where you need it, but you don't need 2022. You just need 2016, which odds are if you go into 2022, you probably already have it. Therefore, it's probably not a big deal. How does this look? Well, here's an example of a string that I have with some CSV in here. Frog, 17, yellow pig, Pikachu, and the syntax is I give it the delimiter next. So my string and my delimiter, I run this, and I get my 4 values. I have 4 expressions separated by commas. I get all 4 of them back in a list. So this sends you back a tabular list. You're actually getting back a data set. In this case, one column called value, that's the default name for it. And then each row is a value out of that CSV. You could use other splitters too. For example, I could delimit it by space. If I do that, it's going to look a little weird. I'll get back 2 values because yellow pig has a space in the middle. And so I have frog, 17, comma, yellow, then pig, comma, Pikachu. You can do that, no problem. A more practical way to do this would be to say, hey, I want to take this and cross-apply a list of tags. So in this case, I have warehouse stock items, and they have tags inside of them. And the tag list is a comma delimited list. In this case, there's some additional delimiters on the outside of it, such as brackets and quotes. But if I go ahead and clean it up and do that, I can take a delimited list and return it as rows. So now for each of these different stock items, I can get back each tag it has. And this is pretty cool. No matter how many tags there are, I get a row back per tag per stock item. So I'm splitting up a CSV and seeing what it looks like. And if you're interested in what the tags look like, you can add them in. We can look at them like this. Here are the tags. You can see that they can have 1, 2, 0, or more tags. The number that are there, I don't control that. It's in the table. It's stored as a bunch of stuff. But string split takes care of it for me here. You can group by string split. You can add, you can min, max it, do whatever you're going to do with it. You can do with strings and work with it. This is a great function for splitting up a string and doing so with very little T-SQL. It's very simple, very straightforward. It requires no additional syntax or considerations. It just works. And it works effectively. And again, if you want to delimit by semicolons or brackets or spaces or whatever else you got, it can do that too. It doesn't really matter. Just take whatever your string is and split it, give it a delimiter, test it, and you're good. So string split. Great function. We're glad it's here. I missed this. I wish it was here many versions ago. Thank you, Microsoft, for finally including this. Date bucket. This is reminiscent of earlier when we had date trunk that would take a date time and split it down to a specific time element for you and round it down. This will do the rounding for you and basically bucket it. This allows you to really group dates and times very easily based on a specific date part. Whatever you want. You pick it, it works. The demos make this a lot clearer as to what it does. For example, let's say I have a date time that is 8/29/2022 at 17:25:01 so a very specific date time. I run this and I say, give me the date bucket for the hour. Well, that gives me 17 o'clock, 1700 hours. You can do more than one in here. So this one says increment for every hour, but I could do a bigger bucket. Let's say I want a bucket of every 2 hours. I can do that, and you'll see that my bucket is now 1600 hours. So 16 to 1800 will be one bucket. I can date bucket down to the minute and get 1725. I can date bucket down to the day and get just simply 829. The cool functionality here that makes this really useful, more than just the date trunk, is that I can put this number here and specify the size of a bucket. Therefore, I can create buckets that are 3 hours long, 12 hours long, 7 days long, 5 days long, 4 days long, whatever you want. You can create the bucket any size you want and work with it. Here's a better example that shows all the data from sales.orders, and I took the expected delivery date and I bucketed it down to 1 week, 2 weeks, and 1 month. And again, if you're interested in taking your data and aggregating it into interesting buckets, you no longer have to go and group by date, quarter, month, week, hour, whatever. You can simply say date bucket, get back your bucket, and group by it, and you're done. This is great. You can bucket by anything, minutes, seconds, milliseconds, whatever you want, quarter, it'll do it. And I can scroll down my list and see that for every value in my table, for every delivery date, it bucketized it for me. I can see that it did it for week, 2 weeks, month. And I can go down and see how that changes. For example, here, 1 week, I would plop me in the bucket of 12/21. 2 weeks, plops in the bucket of 12/14. Month, plops in the bucket of 12/1. So, very convenient, very easy to write, simple T-SQL. And generally, your biggest savings here is you can now write T-SQL that's much easier to read, much easier to write, much easier to understand and document. And it will perform probably better than what you had before because you're going to avoid big, complicated, sloppy, messy, ugly stuff that was hard to read. So again, date bucket is wonderful. It and date trunk are similar. They have functionality that mirrors each other a bit, but this gives you more functionality that you can pick the size of your bucket, and it's really meant for grouping and aggregating, doing analytics over your data, and doing so in a meaningful fashion. Here's a fun one. I can build from scratch a series of numbers and do so quickly and efficiently based on a set of parameters and do it fast. I don't need any prerequisites. I don't have to have a special data set. I don't need a tally table. This kind of replaces the need to build tally tables if you don't want to build one from scratch. Another note in this one, if you want to use it, you need SQL Server 22 compatibility level or it won't work. One of those exceptions. Most things don't have that exception. This does. How does generate series work? This looks a lot like kind of how you define an identity. I'm going to say generate a series of 117.1. This means start at 1, end at 17, increment by 1. So in many ways, this is very reminiscent of how an identity column is defined. You have a starting value, you have an increment. In this case, you can define an ending value as well. And there's no limit to how big you can make this. You can make it small, a list of 20 things, or a list of 1,000,000 things. And it's pretty fast. This is quite fast. It's quite efficient. It works really nicely. So you can see here that my result set was a table. It's a set of values from 1 to 17. If I say give me generate series from 100 to 250, increment by 10, I get that as well. This is really fast. It's really slick. And what I get returned to me isn't a CSV or something ugly I have to parse. This is simply a table. I get back a table of data, and I can work with it. The return value is called value by default, but you can rename it if you wish. You can do decimals as well. I can say, hey, start at 0, end at 1, increment by 0.01. Go. And I will get back a table of decimals from 0.00 all the way to 1.00, all 101 values. So this really can use any numeric values you wish. It can be ints, small ints, decimals, whatever. It'll work. You can cast the results with whatever data type you want, and as long as it fits, it'll work. This is a great way to get a tally table for the purposes of cross-applying, outer applying, or otherwise working against a set of numbers for the purposes of understanding data. It also lets you fill in the gaps too. Let's say you need to take the numbers from 1 to 100 and check all the counts within a data set, but you don't want to miss any if they're null or missing. You can simply take your list from 1 to 100 and then left join it to your data that goes from 1 to 100 and then see how many values are there for each and get back your results. So very, very useful. And I think generate series, I think tally table, I think counting or generating lists. Super useful, not hard to use, and again, like everything else so far, it's pretty straightforward in terms of T-SQL. It's not long, not complicated, just really an extra function that you use, and it works, and it's pretty damn efficient. There's a whole bunch of new JSON stuff. Am I going to demo it today? No, I'm not going to demo it today. There are new JSON functions, though. If you use JSON in SQL Server, I'm sorry. But if you do, getting past the apologies and making you feel bad, these are additional functions that can make your life easier. IsJSON can tell you, is a string valid JSON or not? This is very useful. If you want to know if a bunch of garbage that was thrown into a column from an application is valid or not, this is a great test. This is a good way to ensure before you store data in a JSON column that the data is valid. It's a good thing to always validate data when inserting into a table. This is a very simple and effective way to validate is it valid or not. You can check to see if the path for a specific input exists in a JSON string. For example, does a path exist for a certain JSON or not? Again, is it in there or not? You can check really fast, see is it in a giant string or not, and find the results and get them back. You can check to see a JSON object and pull it out of a set of expressions if you want. And you can also build an array out of any number of expressions as well. These are new functions that didn't exist before 2022. If you use JSON and you use it a lot and you work heavily with it, you'll see these functions and you may salivate, jump right to MSDN and say, you know what, Ed didn't tell me enough. I want more. And that's cool. MSDN documents these perfectly, gives you all the detail, gives you examples. You can play with it and figure it out. For this presentation, though, I found this is a little much, and most people don't use JSON in SQL Server, but if you do, you'll know within 5 minutes if these are useful to you from the documentation. Take them, run with them, and love them. If you don't need JSON, skip to the next slide. This here is a giant space-saving, time-saving, hassle-saving feature introduced in SQL Server 2022 window. If you've used window functions at all, you know they can get verbose, they can get long, they can get messy. It's very easy to have a window function take up more than one line because you have to specify the partition, the order, rows preceding, rows following, and so on and so forth. And the expressions in there can get complicated too. And if you're going to be using the same window over and over for many window functions, there's a huge benefit to having it in one place and not over and over and over. Instead of having hundreds of lines of SQL for one query, you can have far less. So what window does is allows you to take and define your window in one place at the end of your query, and then reuse it for multiple partition or order by window functions, such as sum, min, max, median, average, whatever you want. Ultimately, what it does is it saves space. It makes your T-SQL a little cleaner and simpler, easier to read, easier to document, because you only have to document the window in one place now and simply say, hey, here's the window, this is what it does and why, and this is it. And then everything uses it. And done. If you make a change to the window, you can change it in one place, and the effects take place everywhere. Again, this is a huge way to avoid typos and mistakes, because you have 10 window functions all written out, and you've got to make changes to a couple of them or all of them. You're going to have trouble. It's going to be annoying to have to go in there and one by one make changes to each of them. There's just a lot of human error involved, a lot of potential to make mistakes, and we don't want that. So this is a great feature that allows you to clean up window functions in the one way that they are kind of annoying, and that is they get verbose. This does require a compatibility level of 160 or above, SQL Server 2022 or above. It's one of those exceptions. If you have it, great. If you don't have this compatibility level, if you're lower, then you'll get simply a syntax error saying that the syntax isn't found. And what does this look like? Let's go on down to window. Here's a simple example where I have multiple functions I want to perform over a single window. So what I do is down here I use the keyword window. I name it. You can name it whatever you want. You can name it Ed or Fred or Bob or Joanne or something. Or you can just give it a more meaningful name, I guess, like customer window. That makes sense. And then you simply do your usual syntax as, and then I can have a partition, my order by, rows preceding, rows following, whatever detail goes into your window, you define it right here. And then whenever I want to use it, I have the same syntax that I would usually have for a window function, except I'll say row number over customer window. And that's it. I can name my column if I want or not, but that's it. And now I only have this one label here and everything works. Count star over customer window. Max of orders.orderDate over customer window. Notice how these lines here got very short and simple. The old syntax would have been to reuse this over and over and over, and I would have had big long lines of repeated syntax. So the keys here really are reusability of your code, define it in one place, use it in many, and to make it so that your code is a little cleaner and easier to read. If I want to make changes to my window, I can do so right here, and then that change will propagate to all three of my window functions. And if I wanted to add additional functions into here, I can simply reuse the customer window over and over and over and get exactly what I want back. Very convenient, very space saving. It's a really nice add to SQL Server that makes using window functions better in almost every way. And I would recommend using this whenever you're going to reuse a window function multiple times. I recommend doing this. It will make their maintenance easier. All right. Another finally moment was first value and last value. These are really useful functions, and they aren't 100% what they sound like at first, but when I demo them, they'll make perfect sense. These, within any ordered set of data, this will give you the first and last value out of that set based on whatever the order by is. This is not it's not ordering by whatever the column is in there. If I say give me the first value and last value of a date, it's not going to order by the date and give me the earliest and the latest. It's going to take whatever the order by column is, wherever it's defined, and use that for my first value or last value. This can be used anywhere that you have a set of an ordered window. So the order by is really your key here. This is not the same as min or max. If you treat it like min or max, you'll end up with some mistake somewhere. It'll be confusing. How do these look? First value and last value. I have a big example here. We can see that I am selecting a whole bunch of stuff out of here. I've created a window, same window as earlier. And I have a partition by, and I'm doing all this work here from before. These are the same query as before. Row number count max, row number count max. And I've added 2 additional columns on. I'm saying, hey, I know my order by is salesperson person ID. So this window is ordered by salesperson person ID. That's the order for this. I'm partitioning by customer ID. So slice up my data and aggregate it by customer ID and then order by salesperson person ID. This is how I've managed my data in this window. I now want to know what the first value and last value are for order date in that window. In other words, for a given customer, grouped by customer ID, order by the salesperson ID and give me the earliest and latest date in there. That's what I'm doing. So the first order date and last order date will be for a given customer ID ordered by a salesperson person ID. For example, I look here and I see that for this specific order ID, my most recent order date from earlier was this, 8/27, but the first order date is 5/30 and the last order date is 1/2. 5/30, 1/2, and I can go through the set of data and see similar patterns. Do note that there are cases here where my first order date is after the last order date, because keep in mind, this is based on the order of salesperson person ID, not the order of order date. But if you understand your window well, and you know what you're partitioning by, and you know what you're ordering by, this will give you the first value in the set, ordered by whatever you're ordering by, and the last value. This is a great way to get samples, boundaries, example values, and so on and so forth. And you can then return that with each line. So I can have each of my orders for a given customer ID here, and then get back the dates ordered by salesperson ID. This is a great way to get values otherwise you really can't get. And you can see how it's different than min and max. Min says can be the lowest value for a partition. Max says Give me the greatest, min, lowest, max, greatest for a given partition. The first and last value says, give me the first and last based on the order by. So I'm taking an order data set and returning values, not simply all of the values, give them back to me. And you can apply all the usual tips and tricks that you can put into window functions into here. For example, rows preceding, rows following. You can do whatever cool things that you would normally have done. You can bound your windows differently to start at different places and end at certain places. All those cool things you can do here as well. So it's a window function. It's all the functionality that window functions have. And you can really treat it the same way you would treat it, a max or a row number or a count or an average or whatever else. So cool functionality here, extremely useful. Just remember that it's based on the order by. That order by defines what your first and last will be. If you order by customer ID, you'll get a first and last value for the column in question for that customer ID, lowest and highest. Just keep that in mind. All right. The conclusion here is important. I threw out a lot of new functionality here. In fact, this is pretty much all the new T-SQL available in SQL Server 2022 CTP 2.1 as of this presentation. There'll be more in the future, I promise. By the time this presentation comes out, there may very well be more functionality. 6 months from now, a year from now, there'll be much more. The beauty of this is that Microsoft adds more and more functionality with each release. This is a great thing. This means that you have a lot of flexibility and things change and get better with time. The old T-SQL you wrote that took up tons of lines, that performed poorly, that was ugly, may have a solution here in this presentation or elsewhere in the future, or maybe in the past. Maybe 2019 had a cool new function you missed. There's never any harm in going with each new version, checking out all the new functionality that's added in. And see, Microsoft's pretty good about documenting everything in the surface area for T-SQL with each release. So if you're interested, check out release notes to see what's new. This provides everything up to the writing of this presentation, and it's really great. A lot of resources here, and in general, the improvements can save you time. They can make your T-SQL more compact, make them easier to document, reduce your consumption of compute. Pretty much is very important. Again, you have a bill to pay somewhere, whether it's on-premises, whether it's in the cloud, wherever your compute is, using less of it is good. We all know that. It saves money. It saves money. That's the most important thing right here. But it saves time, too. If your queries can get faster, people get their data faster, that is very, very valuable. So this is a huge deal, and this is 2022. There's lots of great stuff here. People have been waiting for first value, last value, string split, things like that for a long time. A long time is distinct from, not distinct from. These are things people have been waiting for. They've wanted for a long time, and they'll make your T-SQL cleaner and better. This is a scenario where you can upgrade, test, and enjoy new functionality. And just keep in mind the compatibility levels generally guide performance. There were a handful of examples here where the new functionality wouldn't work under a certain compatibility level. I noted in every case where that was a scenario, just so you know that, okay, if I want to use is it not distinct from, I can use it. If I want to use string split, I need 2016. Those notes are here for you. Keep them in mind. As always, we're going to upgrade SQL Server test heavily. Don't do so blindly to get new functionality. Be sure you test, make sure things work the way they should. Make sure everything works the way you want it to. If you replace old code with new code to make it cleaner and better, be sure to test, make sure all your results are the same. They haven't changed, they haven't gotten worse, different, anything like that. But again, test, enjoy, play. This is a wonderful, wonderful way to make the best use out of SQL Server you can of this product. It's massive. There is this endless functionality in T-SQL, and it's there for you. Take advantage of the new stuff because it's there, you can use it, and it will make your life better. And it's being released for a reason. People have asked for this. They've asked for it. They've wanted it. This is a chance for you to really make the most use out of it possible and see what else comes out in the future. So this is kind of an endless journey. In a year or two, there'll be more. In a year or two after, there'll be more. So enjoy what's to come. Thank you very much. There'll be more T-SQL coming soon. This is me, Edward Pollack. Feel free to hit me up on email. Feel free to find me on Twitter. Look me up on LinkedIn. Whatever you'd like. I generally update whenever I'm presenting at a conference, whenever I have an article coming out or a book or anything like that. I'll put my content up as much as I can to try to help out the SQL Server community. So feel free to find me. And as always, this isn't a never-ending topic. There'll be more T-SQL coming soon. Maybe even next week. Who knows? There'll be a new CTP. There'll be some new stuff in the RTM. Who knows? Whatever it is, though, there could be more new things coming very soon. So wait for it. It could be very much awesome. Special thanks to all the sponsors who made this event possible. Microsoft's a big sponsor. There are others as well. Data Platform Summit is brought to you by Data Platform Geeks, SQL Server Geeks. This is a great community initiative, getting lots of people together from all around the world to present cool stuff. So thank you very much. There's some prizes available too. I have no idea what they are. I'm sure they're great. I love winning prizes personally. If you like winning prizes as well, follow the instructions right here. Post a selfie, hashtag it, give feedback. And feedback, by the way, is very valuable. Please do provide session feedback. I appreciate it. It tells me where I'm doing great. It tells me where I'm not doing that great. It tells me how to improve. So please provide feedback. Feedback is great. Provide the conference feedback as well. They also appreciate it. Thank you very much. Enjoy the rest of Data Platform Summit 2022, and I will see you soon.